Address classes were the first attempt at splitting up the global internet IP space. Subnetting was introduced when it became clear that address classes themselves weren't a sufficient way of keeping everything organized. But as the internet continued to grow, traditional subnetting just couldn't keep up. With traditional subnetting and the address classes, the network ID is always either 8-bit for Class A networks, 16-bit for Class B networks, or 24 bits for Class C networks. This means that there might only be 254 Class A networks in existence, but it also means there are 2,097,152 potential Class C networks. That's a lot of entries in a routing table. To top it all off, the sizing of these networks aren't always appropriate for the needs of most businesses. 254 hosts in a Class C network is too small for many use cases, but the 65,534 hosts available for use in a Class B network is often way too large. Many companies ended up with various adjoining Class C networks to meet their needs. That meant that routing tables ended up with a bunch of entries for a bunch of Class C networks that were all actually being routed to the same place. This is where CIDR, or classless interdomain routing, comes into play. CIDR is an even more flexible approach to describing blocks of IP addresses. It expands on the concept of subnetting by using subnet masks to demarcate networks. To demarcate something means to set something off. When discussing computer networking, you'll often hear the term demarcation point to describe where one network or system ends and another one begins. In our previous model, we relied on a network ID, subnet ID, and host ID to deliver an IP datagram to the correct location. With CIDR, the network ID and subnet ID are combined into one. CIDR is where we get the shorthand slash notation that we discussed in the earlier video on subnetting. This slash notation is also known as CIDR notation. CIDR basically just abandons the concept of address classes entirely, allowing an address to be defined by only two individual IDs. Let's take 9.100.100.100 with a net mask of 255.255.255.0. Remember, this can also be written as 9.100.100.100/24. In a world where we no longer care about the address class of this IP, all we need is what the network mask tells us to determine the network ID. In this case, that would be 9.100.100. The host ID remains the same. This practice not only simplifies how routers and other network devices need to think about parts of an IP address, but it also allows for more arbitrary network sizes. Before, network sizes were static. Think only Class A, Class B, or Class C, and only subnets could be of different sizes. CIDR allows for networks themselves to be differing sizes. Before this, if a company needed more addresses than a single Class C could provide, they'd need an entire second Class C. With CIDR, they could combine that address space into one contiguous chunk with a net mask of /23, or 255.255.254.0. This means that routers now only need to know one entry in their routing table to deliver traffic to these addresses instead of two. It's also important to call out that you get additional available host IDs out of this practice. Remember that you always lose two host IDs per network. So if a /24 network has 2 to the 8 or 256 potential hosts, you really only have 256 minus 2, or 254 available IPs to assign. If you need two networks of this size, you have a total of 254 plus 254, or 508 hosts. A single /23 network, on the other hand, is 2 to the 9, or 512. 512 minus 2? 510 hosts. Take a second and lock that into your memory.